Hi, this is GK from GK Marine Tech. Today's class is the continuation of refrigeration, and this is the system we discussed in the last video. So here you can see that four important section in the refrigeration cycle. One is compressor, and one is condenser, and then one is expansion valve. It is a metering device, and one is the evaporator. Right? This is evaporator. This is evaporator. This is compressor, this is condenser. In ship, the condenser is not air cooled, it is seawater cooled, right? So this is the system. Now this video we are going to discuss about metering device, that is a expansion valve, thermostatic expansion valve. TEX, they used to Danfoss and all, they used to denote like a letters TEX valve, and a lot of models are there. We are going to discuss two models which is normally used in the ships, most of the ships, TE2 and TE5. TE5 they are using for in AC, TE2 they are using in the refrigeration in the ships. Okay, so we will discuss about how the metering device is working, and what is the requirement of the metering device. Metering device, it will sense the temperature of the outlet of the evaporator. This is outlet of the evaporator. The evaporator coil, it is sensing the temperature here, and this temperature we are feeding into the bulb. Okay, so that bulb is also filled with the same gas which is used in the system. If it is R22, that is also R22. R407, there should be a R407. So when we are procuring this expansion valve, we have to carefully check the same gas we have to buy. Otherwise, it will not work properly. Okay, so above the thermal bulb, inside the thermal bulb, there is the same gas is filled, and depends on the temperature, the gas will expand and it will press the bellow. Okay, so we will detailedly we will see, and the purpose of this, we have to ensure that the compressor inlet always should be in the superheat, 5 to 8 degree superheat. It should be 8 degree superheat, but we don't know, every time we cannot check, monitor and adjust this system. So it should be auto, correct? So it is automatic set, and it will only maintain the superheat of the inlet, compressor inlet. Okay, the gas in the compressor inlet. So how they are achieving this? They are not maintaining the temperature, they are maintaining only the superheat of the system before entering into the compressor. Otherwise, compressor, why we want to maintain superheat? There is a two reasons. One is, we should take all the latent heat from the evaporator. That is a main important thing. And second thing, the return to the compressor should be in gaseous state. It should not be a liquid state, because compressor, if you insert the liquid inside, if you allow the liquid inside, the compressor will get damaged. Okay, so this is the system. Then we will go to the expansion valve. That is a very important, how we are achieving to maintain the superheat, not the temperature. Temperature is only cut in. If the temperature reached here, then the whole system will cut off, the compressor will stop. But that control is very simple. One temperature control, and we are connected to the electrical system and stopping the compressor. That is very easy. But automatic control of superheat, that how we are achieving to the thermostatic expansion valve, we will discuss in this video. This is the expansion valve we are using in air conditioned system, because it is the external the sampling is given. Okay, so I will tell you that what is the sampling, why we are taking from the external means. So this system, how it is working, see, this is a normal valve. It is operated by the thermostatic bulb. Okay, the thermostatic bulb, already it is filled with the same gas, and gas is filled with the bulb, and the bulb is fitted in the outlet of the evaporator. So outlet of the evaporator, the temperature, what is the temperature is there, depends on the temperature, the gas will expand and it will press the bellow. If you press the bellow, against the spring loaded, the shaft will press, and here is the valve. This is the valve. this valve will open and the gas will allow to pass to the evaporator, correct? It has to pass to the evaporator because this metering device is fitted before the evaporator. So this is allowing the gas to the evaporator, and the amount of gas, it is depends upon the thermal bulb temperature, right? So here there is the thing. Here it is having a three forces. We can call it as a pressure. Okay. So one is that thermal bulb pressure, top one. It is we are calling it as B pressure. PB. That is a bulb pressure, and that bulb pressure should be more than against the spring pressure. This is the spring pressure. This is the bulb pressure. This is the spring pressure, and one more pressure is there. Here we are giving a gas. This is the same freon gas in the system, and we are taking the gas outlet exactly close to the thermal bulb location. So thermal bulb location, where it will be fitted after the evaporator coil. So near to that, we have to take a one branch pipe connection, and connect it to this here. Got it? This is very, very important, because then only we can maintain the superheat, correct? So here we are giving the system pressure, is a gas pressure, PG. So gas pressure we are putting here. Spring pressure, it is adjustable, and once set it will be fixed, it will not change. But gas pressure depends upon the compressor running, amount of charge, gas, and everything is there. So this will vary, and this will not vary. Once if you set it, factory setting, it will be okay. Otherwise you can adjust also. So this is normally we don't disturb, and this is the bulb pressure, that is totally enclosed to gas, and it is expand depends upon the temperature, evaporator outlet temperature. Okay. So with these three, these two is towards upside, correct? The spring force is upside, gas force is upside. So we can add these two, and this one will be downside. So what is happening? PB, suppose PB is greater than PS plus PG. You understand this point? Suppose this pressure, downward pressure, it is a balancing pressure, right? One is downward, this 2 is upward. 2 is upward, but this is a variable, but this is constant. Okay. So if you balance like this, suppose this PB, bulb pressure, is more than the spring plus gas pressure, then what will happen? The bellow will expand. You see? See? Bellow will expand. Got it? So bellow expand, what is happening? It is pressing the stem. The stem is connected with the valve in the end. So if the valve is open, all the gas is going towards it. So now what we want to discuss, how it is operating, we know. Okay. But how we are maintaining the superheat? Where is the superheat is coming? Superheat in the sense, if one container, it is having a gas, its temperature is having a one pressure gauge and one temperature gauge. Okay. So if for understanding, you guess this gas is in saturation state. Saturation state, you know what is that? It is the state, change of state is happening. That is a saturation state. So it's a boiling temperature, like in water, boiling temperature is 100, and in this here boiling temperature something minus degrees, for depends upon the gas, freon gas. So, but this gas having a pressure, temperature, if both it is in the saturation limit, like if saturation pressure, saturation temperature, both in the same level, then that is having zero superheat. That is having zero superheat. Suppose if the pressure is less but the temperature is more, you know that latent heat, when the consuming the latent heat time, that is a changing of state time, the temperature will be constant. We studied in the last class, correct? So if the temperature is increased, means what? That means all the gases inside it is converted into gas state, and the temperature start increasing. That increasing is called superheat. That should be above the saturation temperature, 5 degree above the saturation temperature of that pressure. This pressure is also here keep on varying. That is why we cannot fixed in one value. Depends on the pressure, you have to adjust the superheat temperature, correct? So that is why we want to maintain like this. This is the saturation temperature. We have to make it plus 5 degree. Up to that, we have to heat up the gas that is in the evaporator. Okay. So this how this is happening here. Thermal bulb, what is telling? What is sensing? It is sensing temperature, but we are not using directly as a degree. We are converting the temperature into pressure. So now everything coming under pressure. Spring is also upward force. It is equal to the pressure, and the gas in the system, that is also pressure, and temperature we are convert into pressure with the help of bulb, thermal bulb. Okay. So depends upon the temperature, the thermal bulb will expand and it will convert into the pressure. Now all in pressure, so we can balance the pressure. If the pressure is more, means what? Your temperature of the evaporator outlet is more than the saturation temperature. If the evaporator outlet temperature is under the saturation temperature, that means this pressure and that pressure will be same. But even we want to adjust how much you want 5 degree, 6 degree, you need some adjustment. That is why additionally we are keeping it in the spring. The spring is having a bevel gears, and then we have a screw systems and we can adjust it. Okay. So future class I will tell you how to adjust it, how the parameters we have to calculate, and then find out how much clockwise or anti-clockwise to adjust this superheat screw. Normally don't touch it, and this is the system. It is working for the TE5. It's a thermostatic expansion valve. Okay, thermostatic expansion valve. This model number is TEX5 or TE5. Okay, so we have to be carefully, if you procure, you have to see the data printed in the top of the thermal valve, this top of the valve, and then you have to buy the same thing. Okay, so now this is a TE5 used for AC compressor, AC system. For refrigeration system, little difference. This pipe will not be there. You may be thinking, so without that, how we are maintaining the superheat? It is actually external, and we are taking the sample from exactly the location of the thermal bulb fitted. But in refrigeration system, we don't take the reference from the this gas pressure. This gas pressure we don't take exactly from the location of the thermal bulb. We will take internally. I will show you. See, this is the another model TE2. This small one we are using for the refrigeration system. Here see the same system only. We have a spring and bellow and bulb. Everything is there. Okay, but spring pressure we can adjust with this screw. But the gas pressure internally we have taken. You see, internally we have taken the gas pressure. So people may be thinking some expansion valve need the back pressure, gas pressure from the outlet, and some without gas pressure also some expansion valve is working. Not without gas pressure they are taking from the same point. Because what is the difference between same point and external? In AC air conditioned system, the evaporator coil is very big. So the pressure difference between before evaporator and after evaporator may be little difference. That is why for accuracy we are taking the sample from the thermal bulb location. But in refrigeration is a small coil, and not much difference between before and after of the evaporator coil. That is why we are taking internally. We don't take one more pipe from the cold room and then give the connection here. Got it? So this is the difference between the refrigeration expansion valve and air condition expansion valve. Air condition expansion valve having a external sampling, and refrigeration system they are taking the sampling internally. This is an internal type. Okay, but both are working the same, and it is not a thermal expansion valve. That it doesn't mean that it is controlling minus degree temperature. Not. It is maintaining the superheat of the system before entering the compressor. That is the main purpose of the thermostatic expansion valve. With this condition, it will maintain superheat. You need not do anything. You need not adjust anything. Okay. Only gas pressure, your condenser system and the gas pressure you have to maintain. Then the system will take care of every controls automatically. Got it? I think you got the good information about this expansion valves in the refrigeration system and air conditioning system. Continuously monitor my channel, and we will meet in the next good chapter, good video. Thanks for watching.